a very light discussion about the structure and the anatomy of a kidney. So let's suppose here we have a kidney. The outer part of the kidney is called cortex, as you can see in this picture. This part of this kidney is cortex. The inner side of this kidney is called medulla. As you can see this portion, it's called medulla. Okay, now let's talk about the blood supply of a kidney. The main artery which supply the kidney is a renal artery that will give branches to segmental artery. As you can see here, the segmental artery will branch out into interlobar artery that will further divided into arcuate artery, which will branch out into interlobular artery. This interlobular artery will further divided into afferent arteriole, which will go to glomerulus, and after filtration there will be an efferent arteriole which will go into vasa recta or peritubular capillaries, and after that they will lead to venous outflow. So the renal artery is present at L1 level, and the renal vein is present anteriorly to renal artery and aorta. In the very next section, we will discuss about the glomerular structure. The cross-section study of glomerulus. The blood comes from the afferent arteriole towards the glomerulus. This is composed of three components. The first of all, there will be fenestrated capillary endothelium. The second is a basement membrane that is composed of type 4 collagen. As we know, type 4 collagen is present in all the basement membranes. There is a mnemonic used for it, is type 4 under the floor. Yes, the third component of this glomerulus is epithelial layer consisting of podocyte food processes, as you can see here. So all three of these components will make up a glomerulus that will help in the filtration of the products. These are responsible for filtration of plasma according to size and charge selectivity. The function of this is according to the charge barrier. All three layers contain negative charge glycoproteins that prevents the positively charged molecules entry, like albumin. Albumin cannot pass through these charged barriers. The endothelial cells have fenestration of radius of 40 nanometers. The glomerular basement membrane pores with radius of 4, while the slit diaphragm between food processes of epithelial cells, which are covered by thin membrane, have size of less than 4 nanometers. So GBM and slit diaphragm are size barriers. So basically the endothelial cells, these are fenestrated endothelial cells. These are size barrier for albumin, and this glomerular basement membrane and podocyte food processes, these are charge barrier for albumin. So charge barrier provided by negatively charged anion like heparan sulfate and other proteoglycan located on endothelial cells and glomerular basement membrane will repel negatively charged molecules. Albumin has 70,000 Dalton weight and 3.6 nanometer radius. So barrier to its excretion is provided mostly by a charge barrier because the size of albumin is 3.6. So as you can see, the radius, this albumin can easily pass if the size barrier is concerned, but in this condition there is a charge barrier that will prevent the albumin passage. Another function of this is a size barrier. Fenestrated capillary epithelium prevent entry of more than 100 nanometer molecules of blood cells. Podocyte foot process interpose with basement membrane. Slit diaphragm prevent entry of molecules more than 50 to 60 nanometer. The course of ureters. Ureters pass under uterine artery in females or under vas deferens in males, as you can see here. In gynecological procedures, the ligation of uterine or ovarian vessels may damage ureter that will lead to urethral obstruction or leakage. So in this picture you can see the ureters are passing under uterine artery in female or under vas deferens in males.